Hello, this is Rika, an electric workshop study guide. Today's learning topic is to look at the PLC ladder configuration and learn the operation configuration on the time chart. On the right side of the screen is the PLC I/O section. There are 6 on the input side and 5 on the output side. There are 3 selector switches on the input, 3 buttons below, and a lamp on the output side. Learn about PLC ladder configuration. When there is SSA input and no SSB input, internal relay M0 coil operates. 2 timers are initialized to 0 starting from FMOV command T0 through M0 positive contact. This is the first PLC configuration. When the M0 internal relay contact is on, the M1 internal relay enters the self-holding state through the push-button PBA positive contact. Timer T0 operation is executed through M1 contact. Here, the internal relay M6, M7, M8 coils are connected with the lamp. M6 lights PLA, PLE lamps. M7 turns on the PLC lamp and M8 turns on the PLB and PLD lamps. And according to the PBB positive action of the push button below, the M2 internal relay is self-retaining. Timer T1 is activated via M2 contact. Previously, push-button PBA operation turns the lamp on, and push-button PBB operation turns the lamp off. Each internal relay M3, M4, M5 is connected with B contact in front of the M8, M7, M6 coils in the reverse order. Now let's look at the second PLC ladder configuration. There is no SSA input and there is an SSB input. This status information can be known by the internal relay M10 coil. Similarly, it initializes the memory D value and the timer to be used through the M10 positive contact. Pushbuttons PBA and PBB count the number of inputs. In the PBA pushbutton, the counter value is stored in D0 through the increment command, and the maximum value is 3. In the PBB pushbutton, the counter value is stored in D1 through the increment command, and the maximum value is 3. And each memory D0, D1 must be greater than 0. Calculation is started via the M11 internal relay contact. The D0 value and D1 value are added and stored in memory D2. Then, the value of D1 is subtracted from D0 and stored in memory D3. The value of D2 becomes the sum of D0 and D1, and the value of D3 becomes the difference between D0 and D1. Then, the values of D2 and D3 are multiplied by 10 and stored in D4 and D5. However, if the value of D5 below is less than or equal to 0, the value of D5 is set to 0. This is to make the D5 value to 0 considering the case of negative numbers. Now configure the ramp behavior via the push-button PBC. M12 internal relay becomes self-holding through PBC positive action. And the M15 relay below prevents receiving the value input through PBA and PBB after PBC operation. Via the M12 relay contact, the timer T2 signals the M13 coil according to the set value of D4. After that, when the T2 setpoint is reached, the M13 coil signal stops. The timer T3 below also works and sends a signal to the M14 coil up to the D5 set value. The M13 coil is connected to the PLA and the M14 coil is connected to the PLB. Finally, if the user has SSC selector switch input, all memory D values are set to 0 and the timer is also initialized. It also makes the running lamp stop. PLA, PLB, PLC, PLD, PLE, 5 lamps below operate according to the internal relay contact used in the ladder configuration. The one with M0 contact is the first PLC ladder configuration, and the one with M10 contact is the second PLC ladder configuration. If you have an M10 relay contact, you need to take one caution. PLC, PLD, and PLE are already lit in the second PLC ladder configuration. Through today's learning, we learned about PLC ladder configuration and operation of each lamp. Now, let's check whether it works on the emulator and whether it works on the RECA sequence simulation.
Input on, wiring breaker. Input on, SSA. Press the button, PDA. Release the button, PDA. Press the button, PBB. Release the button, PBB. Press the button, PDA. Release the button, PDA. Press the button, PBB. Release the button, PBB. Press the button, PDA. Release the button, PDA. Input on, SSB. Input off, SSB. Press the button, PDA. Release the button, PDA. Press the button, PBB. Release the button, PBB. Input on, SSB. Input off, SSB. Input on, SSC. Input off, SSC. Press the button, PDA. Release the button, PDA. Input off, SSA. Input on, SSB. Input off, SSB. Input on, SSB. Input on, SSA. Input off, SSA. Press the button, PDA. Release the button, PDA. Press the button, PDA. Release the button, PDA. Press the button, PDA. Release the button, PDA. Press the button, PBB. Release the button, PBB. Press the button, PBB. Release the button, PBB. Press the button, PBC. Release the button, PBC. Press the button, PBC. Release the button, PBC. Input on, SSC. Input off, SSC. Press the button, PDA. Release the button, PDA. Press the button, PDA. Release the button, PDA. Press the button, PBB. Release the button, PBB. Press the button, PBB. Release the button, PBB. Press the button, PBC. Release the button. PBC. Input on. SSC. Input off. SSC. Press the button. PDA. Release the button. PDA. Press the button. PDA. Release the button. PDA. Press the button. PBB. Release the button. PBB. Press the button. PBC. Release the button. PBC. Input on. SSC. Input off. SSC. Press the button. PDA. Release the button. PDA. Press the button. PDA. Release the button. PDA. Press the button. PBB. Release the button. PBB. Press the button. PBB. Release the button. PBB. Press the button. PBC. Release the button. PBC. Input on. SSA. Input off. SSA. Input off. SSB. Input off. Wiring breaker.
Thank you for watching. Check out the subscription and the like button. We will make more and more learning videos. Any other questions would be appreciated if you leave them in the comments below the video. We wish you a nice day.